Greetings, everyone, and welcome back. Episode 3 here. And as promised, we are looking at double identities. Okay, and we're going to quickly derive this. Of course, they are in terms of sine and cos, and we are going to take this from the compound identities, which we have derived one and proved the rest, or derived the rest from the one that we derived. So I'm going to start here with a nice one, sine 2x. Okay, what is this? We know we can write this as sine x plus x, right? And we now know we can use the compound angle identity for sine, and this is going to give us sine x, guess what, cos x, right, plus cos x sine x. But this thing is exactly that thing. Remember, multiplication is commutative. So this therefore should be 2 sine x cos x. End of proof. That's it. Okay. The second one that we're going to derive, and I would say one of the most important identities, is that or one of the important really between the two, because the first one is really easy. You can see this is important because you can easily forget it. But then most importantly, important because it has got different forms. Yeah, hey, yeah, this language. Yeah, well, quite interesting. Yep. So again, we're going to start with the same form. You realize again, I'll keep on using these different letters, not to confuse you, but to just say to you, watch out. It can come as an A, as an B, and all that. I don't want you to memorize this stuff. I want you to understand this stuff. So what if I have an A now, not X anymore? So of course, you start by breaking that down, and we're going to apply the the compound identity now for cos, and of course, in the case of addition, oh yeah, cos A there, and I'm gonna have cos A again minus, okay, sine A, sine A, right? But what is all this? This is cos squared A minus sine squared A. Now, guys, this is the first form. But out of this first form, we can actually derive another form. How? I would like you to remember this all-time identity. This is why we call it fundamental identity, because from this identity, other identities are being born. Okay. From this identity, we know there are other identities like, sine squared. So if I make sine squared A subject of the formula here, it is 1 minus cos squared A. And I've told you also that this thing is the difference of two squares. So always be aware that you can write it as 1 minus cos A into 1 plus cos A. You may find this appearing sometimes in your identities when you're required to prove identities. Then otherwise, another identity, if we make cosine subject of the formula, then we are going to have cos squared A is 1 minus sine squared A. And again, we see difference of two squares there. This can be written as 1 minus sine A into 1 plus sine A. Okay, just watch out for that. So let's derive other identities that come from this. So this is the first form. What about the second form of this? So I'll call it, this is 2.1, this is, if you like, and that one there, maybe we call it 2.2, all right? Because it comes from the second identity. So here, from this, cos squared A minus sine squared A, I'm just going to replace sine there with this form here. So I'm going to write sine as 1 minus cos squared A, and you can see I'm going to have cos squared A minus 1 plus cos squared A, and so this is 2 cos squared A minus 1. This is what? The the second form 2.2. So I think maybe that should be enough, but if it is not enough, maybe then let's try 2.3. As I said, try. So you're going to figure this one out. So what from this one, from the same identity that we just had, okay, what happens if you now substitute sine here? I believe it is quite obvious. Go for it. You probably don't, you know it, you have memorized it, but for now, just for a change, try and derive it yourself. In the next episode, we're going to look at the half angle identity. I hope you guys are enjoying this and you are getting the grasp of it. And really, I'll appreciate it if you give some valuable feedback, of course, and so that we can make this learning better and more efficient. Until then, cheers.